Hello, everyone. I guess congratulations on making it to the closing of the hackathon. Hopefully, it's been a productive, week for you. Probably a bit of a tiring week as well, but if you accomplish some good things, then that makes it all worthwhile. And I know this is my favorite part, especially when we're in the online and in this virtual format, because usually I like to go around to the different tables, see what people are working on, kind of learn that as the hackathon's going on. That's a little more challenging to do in this format, but when we come together for the closing, it's really, really great to see what everyone was able to do during the course of the week. And some of you I touched base with in Gather and elsewhere, but some of you I haven't really even had a chance to do that. So really looking forward to all the presentations. And let's see, we are just about the top of the hour. First of all, is my audio coming through okay? This is a different computer for me, and I'm in a hotel network, or on a hotel network.
Works great.
Okay, great, thanks. And actually, I'm traveling for a conference, and things are starting to pick up a little bit. Looks like there's a chance our next hackathon will be in person. Kind of fingers crossed that we get good news on that. But we'll see how things go. So yeah, I'm going to go ahead and get started. This is being recorded, so in case you miss any parts of it. But I figure, yeah, best to jump in. I know it could be a very inconvenient time for some of you, so we'll get going on that. Okay. Just a quick reminder, you probably all know this, but this is more for people who are tuning in, perhaps just to hear these results that a lot of you accomplished. The whole goal with the hackathon is really to speed up and improve the work that we're doing in the IETF, to work on implementing standards as we're defining them, to get more running code related to those standards that not only helps make the standard better, but makes it a lot easier for developers to go and adopt the standard and implement it and add support for it into whatever it is they're working on. And it's also just a great networking opportunity too, to come together, to have people from different backgrounds with different skill sets who all have a shared interest in these standards, but maybe working on different aspects of it, the implementation of it as opposed to the definition of it, or perhaps a bit of both. And it's really a great time to also engage with what I would say are often not our typical IETF community members, people who come from maybe from universities, from other SDOs, from open source organizations, who are aware of and interested in the IETF, but maybe it's not something they follow on a day-to-day basis. But this is a great time for them to come in and work really closely with people from the IETF. We operate under the Note Well. Hopefully you're all familiar with this, but if not, it's really good to take a look at this. It covers our processes and how we work. You can see the BCPs there at the bottom. I think code of conduct is we see a lot of emphasis on this. It's important to look at that. The copyright, IP, disclosures, all that type of thing. Good to be aware of what the rules and what it means to be participating in the IETF. So good to take a look at that. If you haven't already, suggest you do it ASAP. The agenda, as I said, we've made it to the closing. And after just, I'm not going to spend too much time going through slides. We're going to spend the bulk of the time hearing what all of you have accomplished. I have a screenshot there on the right that I took maybe about an hour ago. And don't panic if you've updated it, like if you've added yourself to that list more recently and you're not in that slide. We're not going to go based off the slide. We're going to go based off what's actually currently on that wiki page. Or I was just messaging with Alex in the background. He uploaded all the slides, all the presentations that have been put in the our project repository. Well, let me go forward a bit. If you uploaded your presentation to this repository, those have been imported into MeetEcho, so we can actually run through them from Miteco, as opposed to you having to share your screen. You can drive it from Miteco. So Barry, if you're up for giving that a try, when we get to that point, we can try going through and doing it that way. So far, it's been working great for me. So I think you may find that an easier way to go through the presentations as well. But I'm getting ahead of myself a little bit. I also wanted to share a reminder about the presentations. And hopefully you were all here for the kickoff. And these presentations are meant to be just, very brief presentations, really just covering what the problem was you were trying to solve, what it was you accomplished, and then just some interesting highlights about what you learned, things you're going to take back into your working group, and perhaps some interesting collaboration with other SDOs or open source organizations, or kind of, other people outside of the IETF working group, or even if you collaborated with another IETF working group that maybe isn't as deeply involved with the standards that you're working on. All that stuff's just, I think it's very interesting to hear. So now, if you can do all that in 5 minutes, that's fantastic. And just, this is meant to be a conversation starter, so don't feel like you need to cover all the nitty-gritty details. Really just give us the high level. That would be fantastic. And we already covered that. And so with that, we're going to switch to just walking through the presentations. And Barry, I'm happy to turn it over to you. And we didn't get a chance to discuss this before, Barry, but do you want to just try driving it from the uploaded presentations into Miteco?
Yeah, I can do that, or each presenter can write their own using the slides. Let's try that. So
Okay.
I'll call you out and use the share preloaded slides option, which is the little piece of paper with the corner dog-eared. Click that, and we'll allow you to share the presentation, and it will pick your own presentation and run your own slides. If you have trouble with that, let me know, and I will run your slides for you. So why don't we go down in what appears to be alphabetical order in the wiki? So rather in the GitHub. So we'll start with BMWG, and the next one will be the DNS header people. So BMWG, whoever is doing that, requests sharing preloaded slides. Is there somebody from the BMWG group who wants to talk?
You can just unmute yourself and
yeah,
just share your own video.
All right, there we go. Rant screen. There you go.
Okay, can everyone see my screen?
Your screen, go ahead.
Okay, so I represent our projects in the Hackathon 112, the containerized infrastructure benchmarking. So the main goal of our project is in continuously hackathon series is to figure out container networking performance impacts by various resource options, and the result will be contribute to our draft consideration for benchmarking network performance in containerized infrastructures. The two main features in this draft is implementing containerized infrastructure with various network models and verifying performance impacts depending on configuration testing. Now, in this Hackathon 112, our main project is to do the benchmark packet loss rate in multiple scenarios with different acceleration technologies for 2V switch, such as BBP and OVS DBTK. And we consider the NUMA consideration to see how it will impact the performance of ZV switch. So inside the hackathon, the scenario we consider is a multiple scenario. So in our 111 IETF hackathon, so we consider the single pause scenario. So this one we consider the multi-pause. So basically the traffic being transmitted from the generator to the true pause and we switch. And in both case, multiple CNI and user space CNI plugin are used to create multiple interface of DNF. And we use a layer 2 forwarding application as an application inside the pod. For the NUMA alignment, we consider inside the multiple scenario. We have 6 scenarios. It can be split into 2 parts. The first part will be the vSwitch same with the NUMA node and the NIC, and the second will be the vSwitch different window node with the NIC. And we denote the CF1 will be the port that receive incoming packet from TZN and then transmit to the CF2. CF2 will be the port that transmit the packet back into the traffic generator. And it's a scenario where both two CNF are placed in different NUMA. Placement of receiving incoming packet CNF and vSwitch is considered. So, and we don't consider both two CNF in different nodes with vSwitch scale, as it will degrade performance as we have observed in single node pause scenario. This is our configuration for our testbed, and this is a design. Basically, we have on master node and the worker node to deploy the pod, and we have the traffic generator to transmit the packet to them. So this is the result that we have achieved throughout our IETF hackathon. The thing that we learned from this result is the first thing that in multiple scenario, VPP outperform the OBS. And the second is the result that we observe from the NUMA alignment. The first thing is the alignment of vSwitch and NIC. And the alignment of vSwitch and SNIC is almost the same. It placed on different nodes will be slightly degrade the performance in higher packet size. And the second observation is CNF and vSwitch. We also that separating placement of CNF will significantly degrade performance by 10 to 50%. And finally, we is a receiving packet CF1 and vSwitch. We observe the reverse result for OVS DPTK and BPP. With OVS DPTK, CMF and vSwitch in the same node, we have higher performance. Meanwhile, in VP, CMF and vSwitch in different nodes, we have higher performance. So for the future, we plan to troubleshoot the CF1 vSwitch and NUMA alignment results, and we consider multiple vSwitch case where we will deploy one vSwitch in each NUMA node, and we will plan to discuss our interesting result with other related community. So to wrap up our presentation, so this is our team member, and we cooperate with the I2 and SF and IPUA team from the SKU team. Thank you for listening.
Thank you, Tran. Are there any questions for Tran? Okay, hearing none. Thanks again, Tran. Good job. Next one up is the DNS editor, Willem.
Yes. So I'm going to try this slide sharing thing.
Yep.
Let's see.
And the next up will be I2 and SF. So get ready. Yep, your slides are up. Go for it.
Okay. Yes. So so the DNS hackathon was actually just a single project which I did with someone else, Tom Kapai, my colleague, and so it's not really DNS but either. And so what's this about? So Roy Arendts has a draft which has been adopted not so long ago at DNSOP working group, which builds upon extended DNS errors. Extended DNS errors is a mechanism in which a resolver or authoritative name server can send back a detailed information about error that occurred to the querier. For example, a resolver can send back to the step resolver or a normal user that DNSSEC didn't validate because the signatures expired, or there was a DS record with no signatures in the zone, or that kind of things. So the DNS error reporting draft builds upon that, but instead of informing the clients what went wrong, it informs the authoritative servers that were serving the broken zones about the error. And so it's actually extended DNS error reporting. And therefore, I know that Roy Arends, who's on this draft, and also Matt Larson, they don't like the funny acronym either, but I do like it. And therefore, I called it either. So this was discussed 1.5 weeks ago during a DNSOP interim meeting. And there what was discussed there, the mechanism consisted that, or meant that the resolver would send a EDNS option to the authoritative saying, hey, do you have a reporting agent for me where I can send my errors? And it was noted during the interim meeting that this breaks some authoritative resolvers. So as an alternative, it was suggested that instead of the resolver requesting the EDNS option, the authoritative could also just send the EDNS option unsolicited. And it was suggested that resolvers would be much more resilient to that than authoritatives towards unknown options. So I proposed that it would be a nice thing to measure at the upcoming hackathon. And some people agreed, as you can see in these meeting minutes. Now, 2 hackathons ago, we also implemented the reporting agent reporting in NSD, our authoritative name server, but this time we went a different way, especially because the authoritative would send it unsolicited anyway. We made a program to do this in BPF. And if you haven't heard about this yet, it's not the old Berkeley packet filter from TCP-dump, but it's it's very exciting and happening. You can run programs in the Linux kernel or very close to the network card, or even on the network card hardware. And what I like about it too, we have been playing it with BPF and at Untitled Labs, is that you can augment existing name server installations. So we made something which is name server agnostic, right? You don't have to anticipate it beforehand. If you have this name server and you want to have this feature added that it can report its reporting agents, then you just load this BPF program and it will work. But it will work with bind, with not, with NSD, doesn't matter. So it's pretty cool. Here's the Git repository. There's all sorts of DNS experiments in there. And here you see an example. So I have this server, either.nlnetlabs.nl, and it's running the either domain. And I have not anticipated the DNS error reporting yet. But to enable it, I just have to do this: clone the repository, initialize a submodule, go to the directory with the option, make load, and I'm done. Now, and you can see here the result from a dig query that it is indeed reporting the reported agent in an EDNS option, report.nlnetlabs.nl. And here's a little piece of the C code of the BPF program. You can see how to configure it with the reporting agent and what option code to use. So I think that's really cool. And we also did ripe atlas measurements to see if resolvers would break if they get this option unsolicited. So I also created a server with a domain that does not send this option, which is called neither.nlnetlabs.nl. And here's the ripe atlas measurement that targets this server, and then also the server which does send the option. I did a very simple measurement. So ripe atlas has 11,000 probes currently, I think. But for the hackathon now, I did it with just 1,000. Doing it with all of ripe atlas is a little bit more work. But it was good to have this experiment anyway, I think. So 962 probes anticipated. The program that processes the results is there in a link too. And what we learned was that 99% of the resolvers don't have an issue with this option. And that the remaining 1% is also a little bit unclear, because actually we had more answers on the domain that did send the option than on the domain which did not send the option, which was the baseline measurement. So, but I think so from initial guess that support is okay. But of course, there needs to be, we need to be do like large-scale measurements to be sure and be certain that this can be done for DNS error reporting without causing problems. Another thing, what we learned and that we more discussed, is that this is like DMARC, right? It gives operators of authoritative of domains, DNS operators serving domains authoritatively, confidence to deploy DNSSEC, because they get feedback from what is happening on the internet if something breaks, etc. So it might be interesting to develop a new draft at the IETF, in which would do dry run DNSSEC, right? That you can try DNSSEC, but if validation breaks, the answer will go to the clients anyway, but error will be reported to a error reporting agent. So that might be some interesting future work. And that's it. We just worked with the two of us on this, because everybody is busy and it works better in a live meeting. But it was nice to do anyway. And I think that maybe we present this a bit more elaborately at DNSOP next week. So that's it. If anyone has any questions, then I'd be happy to answer them.
Thanks, Willem.
Welcome.
Yeah, yeah, thanks for the presentation. I found, the potential of helping with the kind of DNSSEC deployment problem is, as I understand it, is, it sounds really interesting and an encouraging thing to try out. Also, it was interesting to hear you bring up, you were talking about eBPF too, right, at the beginning?
Yeah, that's
and it's, that's prevalent, I think, in the networking space. eBPF gets used a bit, and now I'm hearing it used a lot for dealing with security things. That just, I don't know, it seems like a really neat kind of toolkit in a way to be able to use. So interesting to see you using it in the way you did. It makes me think I need to look into eBPF a bit more, because it seems pretty powerful, pretty flexible.
Yeah, absolutely. Yeah, we sort of made a toolkit. So this uses parts of that toolkit to implement this this option, and it's cool. Yeah, because it's also a feature can be implemented independent of what you're running, and it's very fast, very suitable for dealing with denial of service attacks and those kind
Yeah.
of things.
Cool. Thanks. Thanks for sharing.
Thank you.
Other questions or comments? Okay. Thanks again, Willem. And next up is I2NSF, followed by IPWave. Both of them are Paul, and your screen request is approved. Go for it.
Hello, can you hear me?
Yes.
Okay. So hello, this is Jeon Parjong. This is I2NSF Hackathon project report. So this is a poster for this project. Basically, this Hackathon project case,
We don't have your slides up yet.
Okay, can you see my slide?
No.
Oh no,
It says your
not yet.
screen share has been started, but you haven't
Okay.
done it yet.
Okay.
There you go.
Okay, good. Okay. My name is Jeon Parjong. This is I2NSF Hackathon project report. This is a poster for I2NSF project. Basically, this hackathon, we want to implement distributed network auditing system for I2NSF framework using Hyperledger Fabric as a distributed network auditing system. So as you can see, this is I2NSF framework. So I2NSF user giving the policy, and then security controller translate into low-level policy for the NSF security enforcement. This hackathon project case, I2NSF analyzer collects the monitoring data from NSF using a monitoring interface, and then that monitoring data are stored into Hyperledger Fabric as a distributed database. After that, a security controller has a web server, and it displays the monitoring data into web. So this hackathon project, we use the distributed database based on the Hyperledger Fabric. So you can see I2NSF analyzer collect monitoring data from NSF A and B, and then using REST API, that information will be delivered to Hyperledger, the organization node. This is distributed database node, and then using orderer, and they confirm that storage, and then the data information delivered to control law. Okay, and then it can display that monitoring data into web. So this is the push of NSF monitoring data to distributed data based using REST API. Basically, I2NSF deliver this data into Hyperledger. After that, this distributed database receives that NSF monitoring data from I2NSF analyzer. So you can see this is a JSON format. So right-hand side, so we display the monitoring data. Okay, so this is the system resources such as memory disk. Okay, something like that. And then right-hand side is the network traffic. So this incoming traffic is over that some threshold, means DDoS attack. Okay, so last time we used the centralized database with MySQL. This time we replaced MySQL with the Hyperledger as a distributed database. So what we learned, the usage of distributed database can tackle the possibility of data tampering, such as supply chain attack. And also the distributed database system also denies the failure of single point because we are using distributed database like the blockchain. Overall, the distributed database system can improve the security and reliability of our I2NSF framework. So next step, this time we just store the I2NSF monitoring data, but next time we try to store more data and information such as security policy and NSF capabilities. This is an open source project at GitHub. You can get the source code from this link. So this is 112 source code. And also we have a demonstration video clip. You can click and you can see our demonstration. So this is the member information. We work for Hackathon with the Sungsil University BMWG working group and IPWave team. This is my team members. So also this time you also work for Hackathon project. So Korean folks gathered in the Busan, Westin Joseon Hotel in Busan. We work for Hackathon, BMWG, I2NSF, and IPWave team. So this is the sponsor information. So appendix explains how to install, operate our distributed database system for I2NSF. Thank you for your listening. Any questions or comments?
Thank you, Paul. Questions for Paul on I2NSF before he starts IPWave? Okay.
Okay, may I start IPWave? Okay. So can I start the IPWave report? Barry, can okay.
Please do it. I said yes, but it takes a minute to unmute, so it got cut off.
Okay.
Sorry.
Okay. May I start IPWave report? You can see my slide,
Yes,
right?
please.
Okay.
Yes.
Okay. This is IPWave Hackathon project report. So this is the Hackathon project poster. Basically, this time we implemented IPWave context-aware navigation protocol is called the CMP. So robot, car, and the web server can communicate with each other. So we using IPWave CMP beaker information option type is delivered over World Wide Web. W3C VISS beaker information service specification we used. We deliver information using that standardization format. Also, we demonstrated CV text. Last time we used the wave such as DSRC. So European folks, they are popularly using CV text, cellular vehicle to everything. So in this case, we used simulation-based implementation was done. So I said this IPWave hackathon case, we had two parts. First one is a simulation. Second one is robot car-based implementation. So what got done? So we demonstrated our IPWave context-aware navigation protocol message can be delivered over CV2X using simulation. Also, we implemented the IPWave draft and W3C standard. It is called VISS, Vehicle Information Service Specification, deliver vehicle signal or sensing information to web server. So the first part simulation case, we used the Sumo for vehicle mobility simulation. And the lower part is the OMNet++ with the CV2X module to simulate the car communication based on CV2X. Okay, so this figure shows our implementation of OMNet++. So we implement the vehicle structure to support the CV2X. Also, this is IP version 6 stack, especially the ICMP version 6 is for context-aware navigation protocol. Okay, so we used this stack. So last time we used the L2.11 Wave. Okay, so L2.11 OCB stack. So we using this kind of stack. This time, we demonstrated the feasibility of CV2X. The CV2X is a standard for 3GPP. So in future, I believe IP Wave can take advantage of Wave stack and CV2X stack for vehicular communication. So this is a remote server and the vehicle. So using IP Wave vehicle mobility information message can be delivered over W3C standard such as VISS, Vehicle Information Service Specification. Also, Genevieve VSS, Vehicle Signal Specification, deliver vehicle sensor or other signal information can be delivered over VISS format. So this is also open source project. So you can get the first link is our simulation for CV2X. The second one is robot car-based implementation code. So you can click and then this AI on R1 robotics robot car can deliver its sensing information or vehicle speed information using Wi-Fi to a web server. Second part demonstration. This link demonstrates the CV2X-based context-aware navigation protocol. Okay, exchange. So we work for a whole week with the Sungcheon University BMWG and I2NSF team work together. So this is a team member information. So my PhD student BNMA and my the master student Junhee Kwon. So this is our Korean Hackathon team's members. So this is a sponsor. Also, we have appendix for CV2X simulation, and also we have appendix for robot car implementation and manipulation for people having interesting for our IP Wave project. Thank you for your attention and interest. Any questions or comments?
Well, thank you, Paul. Anybody?
Thank you.
Yeah. Hi, Paul. Hey, yeah, thanks for these great presentations. You always bring great projects to the hackathon, so appreciate that. The CV2X, that was a new one to me. Which standards organization defines that?
CV2X is 3GPP, the third-party partners, right, for 5G, LTE, right? So recently, the 3GPP also working for 6G, but basically Korea case we deployed the 5G. I believe the United States also solving the 5G service, right, for cell phone, right, mobile smartphone.
Yeah.
So the vehicular case also the vehicle to everything case CV2X Model 4 case provide ad hoc fashion communication, which means the vehicle can communicate without the base station. Okay, so in that case, we can providing communication among vehicles to avoid the accident. Also, some detect some obstacles or hazards. It can notify neighboring vehicles of that hazard. So CV2X will be the useful. So European country case, car vendors they adopted CV2X for vehicular communication. Still, United States case, the DSRC wave case, they consider, but I think two technology will be coexist in future. So that's why IP Wave Working Group needed to consider CV2X for Mac and the PHY protocol for IP Wave, the navigation or other application communication technologies. Okay.
Okay. Yeah. Well, thanks.
Okay. Thank you, Charles.
Else? Questions? If not, thanks again, Paul, and yes, thanks for being a regular hackathon participant and always bringing your students with you. That's great. Thanks.
Okay, thank you.
And Oliver, you're next with the ASPA.
Okay, can you hear me?
We can.
Wonderful. Okay, so that was our first active hackathon. What we did, I participated some before as listening in, but this time we said that we wanted to make one on our own. So the work what we did is, and I just go right away in here. So we work since a long time in BGP security, and we worked on BGP sec path validation, the BGP origin validation, and for that we created reference implementation, reference implementations, and a large software suite. What we now employ also for another work at the CyberOps working group, the ASPA, Autonomous System Provider Authorization. And the goal of that is, of this hackathon, what we started this time is to lay the groundworks for future interoperability tests between different implementations, and to create large-scale tests that then can be used to verify the different validations, performance, etc., etc., etc. A very quick explanation how the system in general works. So ISPs or operators of autonomous system routers basically register their data in the RPKI database, and that then will be queried relatively often by validation caches that go out, download the X519 certificates, etc., and then create something, we can call it maybe a whitelist. It's the ASPA information that describes the customer-provider relationships and sends these ones then to the router or a validation engine that the router employs. And our interest for this IETF, for this hackathon, was the communication between the validation cache and the router. So the tools what we used was basically our NIST BGP SRX software suite, where we have the ASPA verification implemented. Actually, we have currently the draft is version 8, but there is an algorithm correction already that was introduced some IETFs back that will soon be added to this standards draft, and we have the implementation for that. The other thing is the RFC 8210 is extended to now also carry ASPA objects, and we made the reference implementation for this. And so we wanted to use our test harness to basically run larger scale tests. So what was our task for this hackathon? We said, okay, we want to go out, we take sample internet scale ASPA data, and we use the CADA reference data to specify, they have very good algorithms to specify the link relations between two ASs. And then we take that and we create the input file format for our software, what basically looks in the following way. You say you have the ASPA, you give the AFI that could be V4, V6, then the custom IAS and a list of providers for these ASs. And what we then also did, we went out to route views and got some BGP updates. Maybe follow another goal. So what did we do? So we went out to the CADA and we got data. Actually, I think it's the data from October 1st, 2020, because currently CADA is revamping their algorithms and do not provide the latest internet data. But for us, it was perfectly fine, because we just said we wanted to have something that if we use already the internet traffic, we wanted to have data that is compiled out of internet topology. This data produced around 70,000 customer registration for us, and that has over 180,000 link relationships. Then what we did was we wanted to down select that, and we did that where we said, okay, if for example, I take 100 routes, 1,000 routes, 10,000 routes. So what we did, we created tools that go out and create a unique AS path. We were not interested in the prefix because ASPA does not look in the prefix. It tries to identify route leaks, basically. So if there's a route leak for one prefix, then it most likely is also for other ones. The validation here is basically on the path itself. So what we did was we down selected out of around, I think it's currently around 800,000 prefixes. If depending how you run the BGP dump on the MRT files, you get up to also 800,000 updates. We down selected that to around 100,000 unique ones, and then from there we said, okay, if you create 1,000, we only want to have the CADA data that contains all ASs within these within the update data stream. So because the other ones, they just would lie in the system dormant. So we created data sets for 100, 500, 800, 1,000, 10,000, and 20,000 unique AS path. And then we performed the ASPA validation. Very quick explanation on the validation, what it is. So if I have a valid, then I didn't identify a route leak. If I have an invalid, then I detected a route leak. If the outcome is unknown, then I don't have enough ASPA information to make any determination either way. And if an AS set is in the BGP path, then it's unverifiable. That is one of the results what I just compiled yesterday night, where we got everything up and running with all the scripts. And it's to be taken with a little bit of grain of salt, because it's a relatively small data set. I think it was around 500 routes. And depending, it becomes much more interesting, I guess, if we go on a higher one. But one interesting thing to see, for example, is already that we selected a large-scale ISP, and we just said, okay, if this ISP is my provider, how many prefixes or how many updates I receive from them, how many paths are valid, and that is 94%, and how many are invalid, that basically means result into route leaks, 3%, and another 3% I could not make a determination. Now, if I turn that around and say that now my ISP is my customer, then of course I don't expect 94% of valids, and that's what we definitely can verify here. So we have 14% of valids, we identify 18% of route leaks, and 68% the data is not there to make any distinction in either way. We didn't have time yet to really dig deep into the analysis of that whole thing. That is something that has to be done now going forward, but for this week, we basically wanted to create the infrastructure that one can start working on that. And so what is still what needs to be done? Currently, our experimentation runs with one implementation on the test against one peer. It starts becoming interesting running this against multiple peers, especially when we go into the performance testing. And hopefully we will see other implementations coming between today and the next hackathon. So then it might be interesting to compare validations with other implementations other than ours to make sure that the validation results are all the same, etc. Further analysis will be of interest is gradual deployment, because what we did here right now, we had an almost 100% deployment of ASPA, and if you roll out a new technology, that is not what happens. So the interest there is to see at what deployment rate start ASPA becoming really making a positive impact on detecting route leaks. The software code of the BGP SRX suite is on GitHub. If you go on GitHub and you just search for BGP SRX, then you will find right away the software suite. The code what we developed for this hackathon, I still want to clean it up a little bit before we put it up on GitHub, but it will be made available as well. And I didn't make a final decision yet if we put it on the IETF hackathon GitHub part, or if we also run it in the examples of ours. But depending what we will do, we will have it at least linked from the NIST GitHub part, so that you can find the code, the scripts, and so forth. Yeah, that's all what I have for today. If there are any questions, please feel free to ask.
Thanks, Oliver. Questions for Oliver? Okay, hearing nothing. Thanks again, Oliver. Appreciate the presentation. And the next one up is the Ansible API generator. And the one after that will be WHIP, so get ready.
Yeah, can you hear me?
I can.
Okay.
Just waiting for your screen, and we see your screen. Got it.
Okay. Okay, thanks. So hello, everyone. This is Chufang from Huawei, and I'm here to give a very brief introduction of our project, the customized Ansible API generator. So the motivation of this work is that we really appreciate the simple and efficient network automation solution provided by Ansible to manage network devices. And we also know that the netconf YARN provides a standardized programming interface. Although the YARN schema is indeed a standard, how the data itself is represented may vary depending on the vendors. However, not all vendors provide Ansible API to manage a device through netconf and vendor native YARN modules. Even though there are some integrated solutions between Ansible and different vendors, the generalized Ansible APIs cannot meet customized requirements. So we really hope that there exists a tool to generate any desired Ansible APIs so that they can be used directly to communicate with network devices through netconf yarn. And these APIs can be used to greatly reduce the workload of developers and allow them to focus on their own business. The following gives some of our specifications, the related drafts which may be used in this project. So what got done, our achievement is the Ansible Gene, an automatic Ansible API generation tool. The generated Ansible APIs could be integrated into Ansible framework automatically and also supports customized input parameter check or functionality. And by making use of Ansible Gene, we have already successfully delivered a L3 VPN service to Huawei device through Ansible Playbook. So the following diagram gives an architecture of Ansible Gene and the entire processing flow. The user inputs are related YARN modules and customized API description XML files. These customized API profiles are used to describe your desired Ansible APIs, which will be called when delivering netconf message to the target nodes. It's very similar to netconf message, but without values carried. Could be an edit config, get or get config, or RPC operation defined in your YARN modules. The YARN parser and XML parser will check and pass the YARN modules and the XML description files respectively. The results are as the input of adapter, which is responsible for generating the internal object of Ansible Gene, and then identified by the Ansible module generator, which will generate the Ansible APIs finally. The generated APIs will be deployed in Ansible environment automatically, which works as an Ansible module. When we issue a netconf request through Playbook, the related APIs will be called and complete the configuration management task. So during this hackathon week, we learned that the documentation is important for involving others. It's even as important as code. We can't expect everyone to know how to use it just by reading the code. And the second lesson we learned is to test early and often so we can have more opportunities to catch bugs and more time to fix them. And also, I would like to thanks to Peng Liu, Chang Liu, Wei-Wang, and Benson for visiting our project and providing very valuable suggestions and great input. Regarding the next step, we would like to support the latest version of Ansible, and we would also want to explore ways to define our Ansible profiles more efficiently. And besides me, there are Frank, Qin, Benwai, and Xiang. Thank you guys for your efforts. And the related outcomes of this project are given here, the open source code and a video demo. Please feel free to visit them so that you can get more detailed information about this project. And further contributions are welcome. Yeah. So this is the end of my presentation. Thank you very much.
Thank you. And are there any questions or comments for Chufang? Okay, hearing none. Thanks again. Thanks for the presentation and for the work at the hackathon.
Thank you.
Lorenzo, you are up with WHIP. And Lorenzo has the magic, so I don't have to approve his sharing.
Oh yeah, sorry, I didn't realize that. Apologies.
I don't care. Go for it.
Okay, so this will be a brief report on the interoperability tests on WHIP, and just to summarize for those that are unfamiliar with it, WHIP comes from a recently formed working group called WISH, which stands for WebRTC ingest signaling over HTTPS, and WHIP is the name of the protocol that is being standardized there. And it recently went to version 0.1, which was actually the main version that we tried to test in these interoperability tests. And we basically wanted to cover two specific aspects. So first of all, we wanted to make sure that WIP client and servers could actually talk to each other using the WIP signaling protocol itself, but we also wanted to take advantage of this chance to also test the WebRTC exchanges beneath, mostly because most of the endpoints that I'll talk about are not based on WebRTC, which means that they do not share the same library that browsers use. And so it was a very unique chance to test heterogeneous WebRTC stacks instead, which can be a bit more problematic at times. And we actually did a few first interop rounds among a limited set of implementations a few weeks ago that I documented in a blog post that you can read there if you want. And at the time, we had 3 clients and 3 servers interacting with each other. And basically, the results that we got from that test that eventually were successful basically helped us identify a few set of key issues in the 0.0 version of the document. And basically, 0.1 most of the issues that were addressed in 0.1 actually came out of that interop round, which was quite helpful. And this time around, we wanted to test more implementations instead. And so we ended up testing 4 different service implementations, including one that I wrote myself, one that Julius wrote, Galen, Sergio wrote the integration in the Millicast endpoint, and Cameron integrated these into his own SFU called that SFU. And for clients, we had 6 different clients instead that we could test. And both servers and clients, basically almost all of them used different WebRTC stacks, which is why it was quite interesting to see how they fared with each other. And the end result was, in a nutshell, this. So it was mostly successful, and actually more successful than the picture there suggests. Basically, just to give you a quick understanding, a green smiley meant that everything worked fine out of the box. A yellow smiley means that we had to tweak something in either client or server to get something working. Red meant that nothing worked, and so further investigation is needed. And orange meant that we couldn't test due to something that was actually unrelated to WIP itself, so like CORS issues or stuff like this. And I tried to summarize most of these reports, the different results in these slides. I will not go very much in detail in all of these reports because they might take more than the 5 minutes that I have, but just to give you an idea, for instance, my client died when he tried to talk to the dead SFU WIP server because it made some assumptions. And so actually some assumptions that were made out of the documents were the cause of some of the problems that we experienced. In this case, my client assumed that the location header was always available and that the SFU didn't provide it. And so basically that ended up in the crash that I eventually fixed. And so, and there were a few similar issues as well. I should clarify that in this slide I meant, I put WIPI, which is the Raspberry Pi based client that Tim wrote that basically didn't succeed with neither Galen and the SFU. And this was true up until a few hours ago. And the cause was basically a nice interop issue between the Teams stack and the Pion stack, which is Go-based. And eventually Tim managed to find out what the issue was, which was actually more related to a firewall issue rather than ICE itself. And he also had to address, again, an assumption that the Pion stack made with respect to the usage of MID in WebRTC, which again was an interesting side effect of this test that helped us identify a WebRTC related issues rather than a WIP issue. And then there were some other issues related, again, to either to assumptions or hard-coded assumptions, because, for instance, some clients couldn't talk to some servers just because each of them were hard-coded to use one codec rather than another. And so in this case, this isn't really a failure in how they use WIP, but mostly a failure in actually ended up into a successful negotiation between the two. Maybe because the client only offers VP8, the server only accepts H.264, and so you end up with a session that will not work, basically. And apart from this, it was mostly issues, for instance, related to self-signed certificates not being accepted, which made it a bit harder to do tests locally, these sort of things. And a few other assumptions like CORS issues or missing support for bearer tokens, which is something that we actually want to look into sooner or later. And really, to summarize, what we wanted to really focus on in this first round was basically really focusing on the basics. So trying to get the WebRTC stream to be published using WIP, possibly trickling candidates and checking whether or not an audio and video stream is actually consumable on the other end. So we didn't want to really push it beyond that, mostly because this was the first time we all met together in order to try and do a larger test among each other. And what we really want to test next is actually going a bit further than that. So for instance, making sure that the authentication using tokens actually works as specified in the documentation, how to properly use the location and link headers to address WIP resources and automatically configure stun and turn. And this will actually be useful to do in environments that are actually more limited in terms of actually setting up a peer connection than the more open setups that we had right now. Addressing also ISPER stars and related risk conditions, which is something that we are actually discussing right now in the working group. And it's something that we haven't had the time to actually look into as far as the different implementations are concerned. Plus some issues related to sessions cleanup, which isn't always done properly by all clients and servers, which means that you can end up sometimes with orphan sessions and things like this. So it's definitely something else that we need to address in future interop tests. And to conclude, this is the interop testing team that worked together in these past few days. So Sergio is actually the WIP champion for this hackathon. Then there was me, there was Tim Panton, Dan Jenkins, Cameron Elliott, and Alberto Gonzalez Rastoy as well. I don't know if there is any question for me. Thank you.
Thanks, Lorenzo. Questions or comments for Lorenzo?
So yeah, thanks for the presentation. I have a question for you. Which video conferencing tool did you use for your team to collaborate?
No, actually, yeah, that's the funny thing is that WebRTC developers tend to communicate in real time as low as the real time communications tend to be as low as possible. So we try to use mostly synchronous communications, like we might engage on Matrix or Twitter or any kind of messaging platform. So it was mostly these kind of interactions rather than having a conversation like we're having right now. We tend to be quite lazy and just chat instead of talking to each other.
Okay, and just one other thought, it'd be interesting on your slide, some of the problems you identified you've already fixed. So to have I'd put like an extra big smiley face on those, the ones that.
Yeah, that's true. Yeah, I had some problems trying to actually frame this one because the yellow ones should actually be a bigger smile because it's an issue we fixed rather than something that we had to fix, and so it was a bit more of a frowny face. So it may be more of a messaging, a pure communication on my side. So I'll definitely fix this next time. Thanks for the feedback.
Yeah, well, thanks. Great project, and thanks for sharing.
Thank you.
Other comments for Lorenzo? Okay, thanks again, Lorenzo. And Stephen, you're up next with augmented packet header diagrams.
Okay, can you see my slides and hear me?
Yes, we can. We can see you, the slides, we can hear you.
Excellent. So, hi everyone, I'm Stephen McQuiston from the University of Glasgow, and I just want to briefly talk about the work that we did this week on the machine readable documents and their tools project that we proposed alongside Mark Petit-Huguenin. So this is a fairly broad project, and it's really an umbrella for a variety of projects that are trying to use tooling to automate different aspects of the draft authorship and standards publication processes, and of the sort of subsequent processing of these documents. So just to give an idea of what we're talking about, this includes tools that are used to generate standards documents or drafts and RFCs. So that's things like computer specifying that Mark will talk about next. It also includes formal and sort of semi-structured languages like ABNF and Yang, the augmented packet header diagrams work that I'll talk about, and the quick packet notation that some of you might be familiar with. On the other side, we are also considering tooling that derives meaning from drafts. So that might be using natural language processing, run over drafts and documents, or it might be parsers for these structured languages here. And in terms of what we want to do with the documents, we're thinking about things like automatic parser code generation, so generating parser code for the protocols that the documents describe automatically from the documents themselves, or producing mathematical proofs that demonstrate that the document describes a protocol or something that is provably correct. As I say, this is quite broad, and we're really trying to be as inclusive as possible for all of these techniques and tools and languages. But this week we worked on two main projects. As I say, Mark's going to discuss his work on computer-aided specifying, but I'll just briefly update you on our work with the augmented packet header diagrams format. So just to briefly introduce this format, we find that most documents that are specifying protocols do so with a sort of broadly similar format. So you can see in the right-hand side here, we have this ASCII packet header diagram, and then below that we've got this description list of each field describing the length of the field and its contents. So what we've done with our work is we've sort of regularized this format so that we can parse it out of the documents that use it, and then generate parser code for the protocol that that document is specifying. And what we've done is we've done this with really minimal change to the format as it's typically used today. And the idea here is that we want to limit how much effort document authors have to put in to changing their documents and the way they write their documents to be able to support our format. And this really balances the sort of structure and uniformity that we need to be able to parse these descriptions out of the documents with the flexibility that you actually need in the real world practical use of these documents. And we've got prototype tooling that supports this input format. So you run our tooling over a draft, and it will produce parser code for any protocols that are being specified using our format. And it produces code in Rust that will then let you parse out packets in that protocol. We're seeing some adoption of the format. So the TCP BIS draft that's going through TCPM uses it. And so in essence, you can take that draft, run our tooling over it, and automatically generate a TCP parser. Of course, there's a lot more information about all of this. We've got a draft that specifies the sort of rationale behind what we're trying to do with the format and that describes the format itself. The draft also has pointers to the GitHub repositories with all of our prototype tooling in it, and any contributions and any comments on it are more than welcome. So in terms of what we did this week, we had lots of very good, very useful discussions about the particular language that we use in our format. So our format uses sort of structured English phrases to indicate where we start a definition. We had lots of discussions about how these phrases could be improved so that they're actually better for humans to read rather than thinking too much about machine readability. Beyond that, we also considered what we might be able to do to mark out the structured text components of our format so that when we pass drafts to the RC editor for publication, that they're not actually edited out and no longer become parsable by our tool. And finally, in terms of our prototype code, we started working upon adding flexibility, so adding more languages that we can produce parsers in, and adding robustness. So we want our tooling to be able to run over every draft, even if it doesn't include our format. And we've really started working on adding that robustness. And in terms of what we do next, that's the sort of two strands that we're going to pick up on as we move forward with it. So all in all, it was quite a productive week. A lot of good discussions with people that haven't been engaged with the work previously. So it's been really good to see some new people. And thank you to everyone that came along to the project table and discussed their work with us. Really appreciate it. And I'll take any questions that anyone has.
Yeah, great presentation. One question, if I wanted to try this out on a draft that I have or even an RFC or I guess probably on a draft, right? Because I'll probably have to change some things.
Yeah.
But anyways, where can I go to get kind of a prototype version of this?
The best bet is to find this draft on the data tracker, and we've got links to the GitHub repository at the bottom of the draft. So all the tooling is available. It's the tooling itself is written in Python. The instructions should be hopefully reasonably clear, but if there's anything at all that comes up as you try to use it, then happy to take any feedback or any comments.
Great. Thanks, Steve.
Cheers.
Anyone else? Any questions, comments? Okay, thanks, Stephen. And Mark, you're up. And we see the slides.
Hello?
Yep. And we hear you. Okay, go for it.
Okay. Why are my slides truncated on the left, right? Huh. Okay. Right. Okay. Hi. So my name is Mark Petit-Huguenin, and as Stephen said, participated in the project Umbrella, which is about machine-readable specifications. So this will be, I will start with a quick introduction of what computer-aided specifying is, because I think that there is less than 5 people on the planet who knows what I'm talking about. So it started a long time ago, and the goal of this project is to ensure that examples in RFC are correct, because sometimes they are not, and because programmers generally look at examples when they write their code and not at the normative text, then we get implementations that are not interoperable. So basically, computer-aided specification is a document which is written in a format which is called ASCII doc, which is not a markdown, but it looks like one. And the big advantage of this format is that it's extensible without having to modify the code. The XML to RFC renderer is in fact provided by the Metanorma project that some of you may know. So I wrote an extension, well, extensions to ASCII doc that permit to add code inside a document. In the same document that will be your internet draft or your RFC, you can add code. And the most important thing is that you can evaluate some of this code and put the result of this evaluation in the document itself at the same time it's generated. So here an example of that, which is taken for 88 something. So the idea is that on top, the block on top is a computer-aided specification. Right? You have code, which you can recognize because there is a greater than, which is called a bird mark on the left. So this is code. And then underneath this, you have text, where you have this code macro, code colon, and the code in between bracket, which will be evaluated and the result inserted into the generated text. So in the middle, you have the command which is used to do that, and there is one command that does everything, and it generates XML to RFC, text, HTML, and PDF format for this document. And on the bottom, you have the result, what will appear in the actual document. And you can see that the macro is replaced by the values that are in fact calculated instead of being filled manually by the author of the RFC. The problem of that is that, in my opinion, this is not enough, right? Programmers are still programmers, and their main output are still bugs. So I needed something better than this that can guarantee that the examples are correct, right? So there is 2 ways of doing that. You can have verification tools that verify that the examples are correct, or you can go the less easy way, which is to generate examples that are already correct by construction, right? So you still can verify them, but if you forget to verify them, they are still correct. The problem is to do that is that you cannot use any programming language, right? All programming languages are equivalent to each other except for their type system. And in this case, we need a type system that can encode higher order logic, right? Which there is probably 3 programming language that can do this. And the one I chose is IDRIS2, which was designed at the University of St. Andrews in Scotland. So I am done with the computer-aided specification. Now what I am working on is to provide some library in IDRIS to solve common problems that internet draft author would have, right? And I am working on a lot of this stuff. One of the simpler and most accessible to everyone is ABNF, right? A lot of internet RFCs contain ABNF. So you can see on the bottom an example of, in this case, how this library module works, right? So I designed the domain-specific language, ADSL, that can be used to define ABNF grammar, right? So here I define alpha, which is probably the most well-known rule for ABNF. And then here on the top, I insert the serialization, if you want, of this. And the result of the serialization is what you have underneath. So not only it print a correct, syntactically correct string, but it also format it, right? It does printing. So if there is not enough size in the line, it will wrap up the line and do the right thing according to RFC 5234. But this is not enough to generate an example. Okay, remember, my goal is still to generate an example which is correct. So my first idea was to generate example from an ABNF, but this is a terrible idea. And the reason for that is that an ABNF cannot describe all the constraints that you have in the PDU it is supposed to describe, right? And I found a really nice example, nice because it's short. It's a symbolic expression that everyone who wrote Lisp code should have seen, right? And this is a very simple version of SX, which I use basically for machine-to-machine transfer, right? Here, if you look at the second rule token, you can see that there is a number, a colon, and then a number of octet. The problem is that the number of octet it should be, in fact, the value of the number before, right? So there is 5 colon, it should have 5 octet after this. You cannot encode that in ABNF at all, right? So this is why this is a bad idea to base an example on its ABNF. Now, what we want is to be sure that an example we generate is also correct according to the ABNF. So the right way to do that is to generate a type for a symbolic expression and eventually a DSL that make it easier to do. So SX are easy, are simple, so the code fits inside the slide, right? But how to be sure that the printable value of that type, which is an example, is correct according to the ABNF? That was what I worked during this week at the hackathon. So the solution was quite simple now that I know what it is. Right? So the idea is to build a proof that this string is correct. Right? And this is why we need things like IDRIS and that are not. We need to use a programming language like IDRIS because this is the only one that can build a type which is actually a proof, right? So here we are saying that we can build an instance of the type valid only if the string that we pass and the grammar that we pass are correct, right? So if the string is correct according to the grammar. And so I designed it in a way that you can directly insert a value of this type and it will display the validated string. So the last thing that one needs to do is to write a conversion between the type, which is the perfect thing, and this, right? And this is the thing that you see At the bottom, this is just the type. Obviously, the implementation is missing and will not fit. But the idea is that we transform an instance of something of type symbolic expression into a list and into a proof that this list is valid for the grammar SX, which is on the right with a small s. Right? And then it's simple. You just have to insert the result of all of that in your text. Right? So this is how it's done. You have our function example. We use the DSL to define our symbolic expression, and it's automatically verified, and it generates the text that you see on the bottom, which cannot be an invalid symbolic expression. This is impossible unless you tweak your compiler. So this is all I have. This is thanks to a lot of this discussion this week with Stephen, Colin, and Robert, and Jean, and Lucas. You can find all the documentation and all the links are in the spec, which is an internet draft. Even access to the tooling, there is a link inside to find it, which can be retrieved with BitTorrent. We will be releasing the version 15 this weekend that will contain these new things. And that's all I have.
Thanks, Mark. Yeah, I'm really excited about both the stuff that Stephen was talking about and this stuff. Automating this stuff will help us a lot. Anybody have questions or comments for Mark? Okay, hearing nothing. Thanks again, Mark. Appreciate the presentation. And with that, we've gone through all the presentations that I think are uploaded. Does anybody have a presentation that they think I missed?
Hey, Robert, this is Hannes. I thought that I uploaded mine, but I may be just wrong. And I failed to upload it.
Well, if you want to just present it from your screen, go ahead and request screen sharing, and we'll put you on.
Perfect. I will do that. Okay. Give me a second. I'm trying to find. Can you guys see my screen? Does it work?
We can. Yes.
Okay, excellent. Give me a second. Perfect. Okay. So we worked on a little bit broad topic in some sense on IoT security, and what that meant for us was we wanted to implement specifications developed in these different IoT security working groups. We had been doing hackathons on those topics already for a while, so we have a pretty good code base, I would say. But needless to mention that there's obviously a lot of continuous development in those groups, and some of the specifications are not finalized, and we try to integrate them to each other, like the core groups. The core group develops co-op, and it's protected using DTLS, and then there's firmware updates using suit, and so on and so on. Many other groups sort of fall into that bucket. And what we also wanted to do, like we did in previous hackathons, was to offer tutorials to help new participants get up to speed a little bit faster, because some of the development is embedded development is complicated, and there's focus on low-level programming. So we thought that would be useful. Again, of course, to make it more exciting, we prepared new presentations, new topics, and as I mentioned on this slide, we managed to hold all the tutorials. The slides and the recordings are available. Some people asked for it because they, like, time zone differences and other commitments made it difficult for everyone who was interested to participate. We also managed to write some code, of course, such as sort of extensions, IoT-specific security extensions to TLS, and worked on Embed TLS code. Also, code for Wireshark was developed and released, and I think it's already merged into Wireshark, so you may be able to benefit from this if you use Wireshark. We also enhanced an open source implementation called Bakama that is used as a lightweight M2M client. Lightweight M2M is a device management solution that uses co-op and a variety of extensions. So that was extended with security support, BSA crypto, and the connection IDs that I mentioned previously, and so on. Some other folks didn't manage to get that far to really sort of release the code, because obviously first you have to understand the real-time operating systems and the details of it before you can extend them. So they did the deep dive on those and figured out on how to integrate their favorite projects. And I expect this work to continue, of course, after this week. So we may have some results also in the next couple of weeks or months before we meet again at the next hackathon. While doing these implementation activities, various issues were identified with specifications, specifically in the suite and the deep working groups, and here are some of them that I have collected. I won't go into the details. You can probably going to be discussed at the meetings next week, so I skipped that. And what did we learn? We made some progress on the hacking side again. Most of us have been at numerous events already, and so there's obviously a lot of experience and quite fluent already with various different projects and embedded RTOSes, etc. We've again managed to identify some open issues with the specs, and I believe the tutorials based on the participants were useful again. I enjoyed it, listening to what the other people are up to. And we also had good discussions, not only during the tutorials, but also during the week in general, which I think is a big plus now that we are all traveling less and have fewer contacts. These type of events are really enjoyable. We did, however, notice that the online fatigue or hackathon fatigue settles in a little bit. Sort of this, what we were used to, like sitting together in a room and having full attention to the programming, isn't quite there when you have all sorts of other activities going on, and so that makes it really challenging to make good progress. I don't know if other teams had similar challenges, but we definitely had. And so I think we tried to make the best out of it, and I'm happy that we organized this. I also promised all the participants of our hackathon to send them hardware. Thanks to our bureaucracy, that's going to be delayed, and I will only send them the hardware in the next few weeks. But it's still maybe a takeaway that is besides the experience and the code progress, there's something to hold in your hands as well. We had a bunch of different folks participating, 2 newcomers who joined, a number of people who we had already worked with. So there was a lot of familiar faces in our club, so to speak. So I'm happy that they keep coming again and again from hackathon to hackathon. So if there's one takeaway for you, if you care about IoT security, you might want to have a look at the tutorials, and the link is on the right-hand side. So yeah, that's all from my side.
Thomas,
Yep.
Please do upload your slides to the repository so we have them there.
Okay, I thought I did. Sorry if I. Who knows where I
That's fine.
uploaded them to?
Yeah, it's who knew? They're floating around on the internet somewhere.
Yeah, I don't know. I didn't
Yeah,
find
they're
them.
somewhere on GitHub. Easy to find.
Does anyone have questions or comments for Hannes? Okay, hearing none. Thanks again, Hannes.
No problem.
And so that ends the presentations. Are there any others that we missed?
Benson has one he uploaded, and Benson, I can share your slides if you want. Are you able to join us through audio and speak to them? Yeah, I don't hear you yet, Benson.
We see you unmuted.
Okay, is that better?
There we go.
Oh, yeah, I hear you now. So,
Great.
Let me okay, we're just gonna try this. Oh, no, that didn't work. Okay, let me try something else. Huh. Okay, I'm having a hard time sharing your slides here. Let me download them and share them outside of. Let's see if that works better. Hold on just a sec. Okay, I'll try sharing again one more time. Huh. It won't. I get an error each time I try to share.
Okay. Can most people see the link? I guess the slides are online, so you can advance them yourselves. I'll paste it in the chat again, and then I'll start.
Let me see if I can share them. You never know. So, okay,
yes.
People see it? All right, so just say next when you're ready to go to the next one, Benson.
Okay, thank you very much. So this is kind of the usual topic, maybe one tax API. But a lot of the communication security heavily relies on IETF standards. So move to the next slide. Barry, next slide, please. Okay, so I'm going to look at standards that are needed for e-commerce. And motivation is that, at least in Kenya, people want to introduce taxes on digital payments, in particular for international payments. But this can be time-consuming because it means you need to register both where you're operating and everywhere you want to sell. So if there's some kind of standard tax API, this might help people, and particularly if they can register in one place and be able to sell in many others. So next slide. So basically looked at literature, initial design specification, learned a little bit about Go, tried to make a prototype just to look up tax rates using ISO codes. So these will allow you to determine locations. They don't all quite correspond to tax jurisdiction, so maybe some extension of that might be needed. Okay. Next slide, please. And one of the things we found is the API, and it mostly covers the North America and Europe, so not so much for African and Asian countries. And so we kind of want to see if we can get something that will provide a similar solution in most other countries. So this next slide. So this API is nice in that it provides you an easy way to practice. It doesn't solve the double registration problem. But it still gives you a way to get localization, get the tax ID registered. So if you're a business, you can actually reclaim tax on purchases. And as you said, it covers mostly the US and Europe and Canada. Okay, next slide, please. So we want to be able to get the tax rates, and typical things that you might want it to give you is an identifier, the tax type, whether it's active, inactive, the region code, the percentage, and if there's a state or a region in addition to the country, and some information about last updates, just so that you know if what you're using is current. So that's what's in this Stripe API. One could use this as a basis for extension. So next slide. So there are a number of other bodies that do standardization. EMVCO is probably the most common one. So they do the 3D secure thing. PCI is also commonly used for verifying how data centers should run. OECD has taxation guidelines, which are helpful for understanding the area. And kind of business to consumer taxes are priority for OECD, that they suggested at an in-person meeting 5 years ago, but not much has happened since then. Relevant RFCs in particular is 5280. So that's used in both 3D Secure, which is kind of commonly used, and also Secure Electronic Transaction, which was proposed but hasn't seen much adoption. Though it looks like it would be easier to modify to include taxes in the workflow that they have for Secure Electronic Transaction. Next slide, please. So what next? We want to try and do a more complete API specification, add examples where we have direct links to tax authority for payments, so that this can be automated. And need to consider security and privacy aspects in more detail. So some of the RFCs that are being considered could possibly be implemented in the standard that would allow this to operate efficiently. And then try implementations in other languages just to see that it's easy to generate this. Next slide. So thanks. Team was composed of myself and Moses Gaduku, and got a lot of feedback from Ali Hussein. And thank you for your attention.
Thanks, Benson. Anybody have questions or comments for Benson? Okay. Thanks again. I'm glad we were able to get your slides up.
Thank you.
Anybody else? Is there any other slides that, any other presentations that someone would like to make that we haven't done yet? Okay, back to Charles.
Well, thanks everyone for all of those great presentations, and we will will just go ahead and briefly wrap up then. In addition to all the great work that all of you did, I want to give a big thanks to Sia and Nick for sponsoring this hackathon. Really appreciate the running code sponsors that we've had, especially through these, when we've had to do it online. I think it's great that we have the sponsors there, and I hope that we continue to have a good flow of sponsors. So if this is something that interests you, it's called the Running Code Sponsorship. There's information about it on the wiki. Sorry, not on the wiki, but on the IETF web pages. If you have a hard time finding it, I should have included a link here, but I didn't. But I can get that information to you. But definitely big thanks to Sia and Nick. And so the next IETF meeting is the dates are set. We don't know yet whether it's going to be in person or virtual. If it is virtual, we'll run it the same format as we did this one for the full week before IETF 113. If we do manage to meet in person, we will go back to our format of having it on the weekend before. So stay tuned for more information about that. We'll see what ends up happening. And one way or another, we will have another hackathon. And
we have had the face-to-face hackathons. We've had plenty of remote participation in them, so that will continue.
Yeah. Yeah, definitely. And some of these great improvements in Meetecho and some of the other tooling are just going to help us out with have even better remote participation. Better mechanisms for remote participation. So, Oliver, you wanted to share something?
Yeah, hi. I have a question. So, in case the next hackathon is on site, do you also plan to have a parallel virtual one?
Not a parallel virtual one, but you can join. We, as Barry was mentioning, we typically do have a number of people who participate remotely, and just by either and sometimes bringing their own projects, as you did for this hackathon. So sometimes the champions and the project teams actually remote. Sometimes it's a mix of people who are in the room and some are remote. So yeah, we run it as a hybrid one, I guess.
Yes, because one thing, for example, we used very much the Gather tool to have our meetings within Gather, even though we could have used something else, but we thought, okay, in case other people might be interested in joining in, that would give them the opportunity to just pass by. So that was my maybe the background for my question. If a hybrid hackathon is planned, would then tools for Gather still be available, or would it not?
Yeah, I think we're going to be using Gather for hybrid meetings for the foreseeable future. So I would expect that that Gather will be available for 113, whether we're in person or not.
Thank you.
Yeah, great question though, and let's see, and I think that is it in terms of the slides. That's it in terms of the hackathon. Huge thanks to Barry. Thanks for running us through the presentations. For me, I'm not on my usual computer, so I think that's why I ran into problems when I tried to share those slides. I had to restart Firefox with the right permissions. So, but I appreciate all your help, and huge thanks to the champions for leading your projects, and really to all of you for participating and for putting together your presentations and sharing them. Really great work to everyone.
Charles,
and with that, I think we will wrap up.
Thanks to Charles for doing a huge amount of work in setting this up. Charles spends a lot of time getting the hackathon running. Well,
it's thanks for that. It's great. incentive though when I see all the wonderful work that gets done. So it's easy to motivate myself to put these things together. And yeah, the Secretariat and a lot of other people do a lot of hard work to make this happen too, and folks on MeTecho and everything. So glad it worked out as well as it did, and we'll have a successful hackathon next time too, either in person or online. So thanks to everyone. I'll let you go, and have a great weekend and great week of IETF meetings next week. Bye-bye.